Hello, everyone. I'm Connor Cahill. I'm here from the DynamoDB team. I'm a security engineer, and we're going to be talking about security, so hopefully you'll stay awake. Hopefully you all had lunch already and you're all relaxed and we can have some fun. The topics I'm going to be talking about are protecting your data at rest, so what you can do to make sure your data is protected, how you can monitor access to your data and what features you can use, and I'll walk through an example of showing how you can alert yourself when certain actions are taking place. Controlling access to your data and talk about some of the fine-grained permissions controls that we have, and limiting access to your network while you're accessing DynamoDB and how you can use virtual private endpoints to control access. So let's look at protecting your data at rest. Earlier this year, we launched encryption at rest with AWS's Key Management Service, KMS keys. And that uses a AWS managed CMK. This is a CMK in your account that is reserved for use by DynamoDB. All access using that key is logged in CloudTrail. The key comes with a default IAM permission policy on the key itself that you can't modify, that it's locked, and it grants permission to all the users and roles within your account by default. Access to that key can be restricted, not directly on the key itself, but on the IAM user policy. And I'll walk through an example of how that can take place and how you could actually block somebody from getting access to the key inadvertently. And another interesting note with this is global secondary indices and DynamoDB streams are both protected by the same encryption model that you have on the table. So if you're using a CMK on the table to protect the table, your GSIs and your streams are both protected. And the streams is a new feature that we launched recently as well, where streams are also protected with the same encryption. So enabling encryption is a pretty simple model. If you go to the DynamoDB console and the default settings, you go and change the default settings so that you can turn on encryption by just flipping one switch. I'll also show you how you can do that with the command line. But the result is you'll see that the encryption flag shows as enabled. And if you describe the table, you'll see that it tells you that the encryption is enabled and what key is actually being used to protect that table. If you go and look in the KMS console, you can see that there's a DynamoDB key. And that's the key that the AWS managed CMK that's in your account that we use for accessing and controlling access. One of the things you can see if you go look at that key, you can look at the grants that are on that key and see when you add a new table to be encrypted with this key, we will add a grant that grants DynamoDB access so that we can do backups and we can manage the table itself. And so there's an encryption context that points to what table is actually encrypted for each key. So if you encrypt 10 cables, you'll see 10 different grants in there so that DynamoDB can access the key. When the key is used, so when a user goes and accesses an encrypted table that's protected by the key, or when the user creates a new table, you'll see CloudTrail logs. And in the CloudTrail log, we'll identify who took the action. We'll identify what key was used during that action. So this would be your normal standard AWS managed key for DynamoDB. We'll indicate that it's coming from Dynamo, because the user doesn't access the key directly. These AWS managed keys are accessed only through Dynamo. And so the Dynamo key is only accessed through Dynamo. And we'll tell you what table it was accessed on behalf. So you know who did it, what table they did it on, what key was used, and that it came through DynamoDB. There are some tricks, some edge cases that you have to worry about here, and one of them is with DynamoDB permissions. The user actually has to have permissions to use this key. They do get that permission by default from the key itself, so the key policy, the KMS key policy, grants permissions to access. But it is possible for you to construct an IAM policy on a user or role that denies access. And so we'll walk through an example. Here I have an administrator, very tightly controlled administrators generating a policy for Jane. And on the policy for Jane, they grant full access to DynamoDB. So Jane can manage any DynamoDB table, can call any DynamoDB API. This is probably not the most ideal policy you would use on an account, but this one works for Jane. But the administrator wants to really lock things down, so they put in a deny that says nothing else is allowed except for DynamoDB, because that's all they intend for Jane to use. And so this seems like it works, like it would be a reasonable policy. But when Jane turns around and tries to create a normal table, everything works peachy keen, because that's all she has, all the DynamoDB permissions. Everything works. However, when she turns around and tries to create a table with encryption, so she turns on, she says the SSE specification and enabled is true, so she's turning on encryption, she gets an access denied error, right? Because she needs to be able to access the key through DynamoDB, and the policy she had denied access. Similarly, if she tries to access a table that's not encrypted, everything works peachy keen. But if she tries to enable a key, tries to access a table that is encrypted, she'll get another access denied, right? Now, what happens here is when she's trying to access the table, DynamoDB has to go decrypt the data key so that she can access the data, and that decryption fails. So she'll get an access denied. So how you can fix this, again, this is probably not the most, this is not a tightly controlled, regulated policy, but you can, in the deny statement, just say, I'm not going to deny KMS. So this is not granting any new permissions. This doesn't give her permission to access KMS. But it does say, I'm not going to block access to KMS. And because she has, by default, access to the KMS key that is used for the AWS managed key, she will get access to this, and her access will succeed. So after this call, she would not have any trouble accessing an encrypted table. There is another edge case that you have to be concerned about, and that is to do with caching and connection pooling. We don't want to access KMS every time you access the table. If we did that, we would quickly overload. We'd add a lot of delay to your access, because a KMS access adds additional latency. And B, it would generate a lot of access logs for you in your account. And so we pool connections. Essentially, we cache KMS access. And we do that essentially for every connection. Once every 5 minutes, we check to make sure you still have access. So it's a standard cache that goes on. When you have a new connection, you'll have a bit of latency penalty, and you'll have a KMS access as well as a CloudTrail record for that KMS access. This has caused problems in some cases where people weren't reusing connections. So if you reuse a connection from the client, if you're running a service and you're repeatedly connecting to DynamoDB with a new connection, the DynamoDB latency is not too bad, but when you start seeing all the CloudTrail logs and stuff, it becomes very expensive. One customer who had this problem with a Node.js implementation ran into, because their application was not doing any connection pooling, and they had on the order of 100 separate service nodes that were contacting Dynamo repeatedly on new connections, they had a substantial latency impact. When they fixed that, the latency went from about 20 milliseconds per call to 2 milliseconds per call. The number of calls that actually went to KMS went from about 600 calls per minute down to about 3 per minute. So it was a big savings for them, and they were very happy. The places where this comes in each of the SDKs and each of the development languages have slightly different models around this. Java's built with connection pooling by default, but it has a limit of about 50 connections. So if you're writing an application where you're running several hundred threads, and those threads may be accessing more than 50 simultaneously, you want to increase this value. Similarly, with the Python toolkit, there's a limit of about 10 connections. There's a built-in pool that supports around 10 connections. And so if you're going to run a Python service that's written in Python, and you're going to have more than 10 threads that are going to be simultaneously accessing DynamoDB, you want to increase this limit. And Node.js is one that has no connections by default. So it has no connection pooling. And so if you are going to do this, you want to create an HTTP agent that supports connection pooling, and set the sockets, set the limit on the number of sockets to what's appropriate. It all depends on when you are, depending on what your application is doing. If your application typically takes a request, accesses DynamoDB, and responds, then you want to have as many sockets as you have threads. If your application is going to go do some work and only access DynamoDB for a portion of that work, then you'll need some ratio. You may have half. So you may have the number of connections in your connection pool be half of the number of threads. We recently, I think about a week or two ago, announced default encryption at rest. With default encryption at rest, all of your tables, all of your backups, all of your streams, all of your indices are all encrypted. They're encrypted with DynamoDB or AWS-owned KMS keys. So these are not KMS keys in your account. So there's no CloudTrail records in your account. There's no permissions needed to access these keys. These are all within and managed by accounts within DynamoDB. We use the same encryption model. So the general model for this is we use KMS to encrypt the data key, and the data key is used to encrypt the data within the tables. All existing tables that existed across DynamoDB for all customer data have been encrypted. We've been doing that over the past few months. So right now, if you have a DynamoDB table, whether you created it today or whether you created it 6 months ago or whether you created it a year ago, that data is now encrypted. Your streams are now encrypted. Your backups are encrypted. So all of that data is currently encrypted. And there's no changes necessary. You don't have to do anything to enable this or to turn it on. It just works, and you're just encrypted. And there's no additional cost, including no change in latency. We were able to achieve this maintaining the existing latency SLA and the availability SLA and not changing any of our latency. We are working with our external auditors to include this in our external audit reports moving forth. Otherwise, how do you know that this stuff is really encrypted? But that's how we're getting that covered. You might, jumping back to this a second, you might have a question about should I use CMK or should I use the default encryption? And it depends on what your mission is and what you're trying to achieve with encryption. If your primary goal for encryption is that I just have my data encrypted at rest, then the default encryption at rest will meet your needs. If the thing is that you have to have a key for some other reason, for a compliance reason or for some internal security reason, you have to have a key that's used within your own account and you have to have monitoring on that key, then you should use the CMK. The net effect from the two are going to be there isn't a big difference in the net effect. You have the data, it's all encrypted with the same technology, and it's protected the same way. So monitoring access to your data. We currently support CloudTrail with DynamoDB on control plane operations. So when you create a table or you modify a table, like updating the table, those are all logged in CloudTrail. It's always enabled. It always shows up in your primary CloudTrail that's available. You can go look at it in the CloudTrail console and see who created a table and when they created the table and all that fun stuff. We don't currently support CloudTrail logging in the data plane. So when someone does a get item or a query, that's not logged in CloudTrail. We do provide, if you need to monitor updates to your table, you can use a DynamoDB stream, which gives you a change log of all the changes made to the table, and you can use that to maintain a log yourself. If you do currently need logs to your table of accesses, we suggest you do that at the application layer, at the layer above DynamoDB. The things you can do with the logs that we are doing, so with the control plane operations, is you can integrate that with CloudWatch Events. And you can set yourself up for near real-time tracking of events that occur within your tables. You can do some interesting use cases. I have one that I'll show you where anytime someone attempts to delete a table, it will send an email message to me to say, hey, Connor, someone's deleting this table. Or someone tried to delete this table and let me know, just as a demonstration of it. You can also do other things like if someone creates a table, but they did not turn on autoscaling, that you can turn on autoscaling automatically if that's your policy within the thing, within your company. So you can set up rules like that behave on this. And I'm going to walk through creating the notification setup. I have this user Bob, and I'm a security guy. Security guys always talk about Bob and Alice, almost always. So I did talk about Jane before just to have something different. But here's Bob. Bob's a little troublesome. Bob likes to go and delete things in test table. And so here I've got this. He's going to try to delete a table. And I put a date command in there just so you can see how long this can occur. And this isn't the CloudWatch events are near real time. They're not real time. They're not guaranteed to be real time. But you'll see what happens in this case. So this was done a couple of weeks ago on a Saturday, and I got this error occurred that when Bob tried to do this deletion, that said, hey, you can't delete the table because you don't have permissions to delete the table. And in my inbox shortly thereafter came a notification that says, hey, Bob tried to delete the table. And if you look at the timestamps on the two, they're only a few seconds apart. So you can see it is near real time. How do you set this up? What do you have to do to go set this up? There's 3 steps. One is you have to configure a CloudWatch event to track the event and to be notified, to trigger a Lambda function. You have to build a Lambda function that will process the event and generate the message. And you build a simple notification service, an SNS topic that will deliver the email to whoever subscribed to this. And so I'll walk through these steps. And it's easier if you do it backwards. And so I'll start first by setting up the SNS topic, and then I'll set up the Lambda function, and then I'll set up the CloudWatch events. And so in setting up the topic, you just create a topic for email delivery, and you create an ARN, and you set the endpoint of where it's going to deliver the email, and this is my email address. And so I go and set that up, and notice when you first set it up, it's pending confirmation. And so you have to go through the standard email confirmation that says, hey, yes, I want to subscribe to this to enable it. And after you do that, you now have a topic set up. I called it email delivery. If anybody publishes a message to that topic, that message is turned around and delivered to me in email. Very simple. I use this for other cases, like I have one set up. I have a similar kind of setup for delivering notifications when IAM changes are made in my account. So now I have the SNS topic set up. I turn around and I go to Lambda, and I want to configure a new Lambda function. And I'm going to author the Lambda function from scratch. So I'm going to start out with a new Lambda function. I choose to use Python. You have a number of different languages you can choose, but I chose to build this with Python. And I call this my DynamoDB alerts function. So it can alert me to different functions. I'm going to use this primarily for tracking deletes, but you can do it for whichever. One permission you need a role for the Lambda function. And I set up the role and used a out-of-the-box permission for SNS topic publishing. So you can just select that from the list. This will grant this Lambda function the ability to publish to any SNS topic in my account. You might want to, in a real world, go back in and edit that policy and say only for the topic that is necessary, in this case, the email delivery topic. But it's easier to just generate it this way by default. And before I go into the actual code, I'm going to show you a sample event. This is what comes from CloudWatch when they call your function. It has a detail section, and within the detail section, there's a section that has the request parameters, so you can see what was passed on the request. And there's a section that has the response elements. This is what was passed back to the caller. And so you have that information available to your function so that you can see what was done. In addition, there's information about who was called, like who made the call. This is called by Bob, and the source came from DynamoDB, and even the user agent, not that it matters in this case, but you can see each of the different pieces of information that are available. And so we're going to walk through writing the function. I'm now into writing Python code. Some of the beginning of this is just boilerplate. These are the different Python libraries I have to include. And then I'm taking that detail message that we just looked at, that event, and I'm taking it apart, pulling out the different sections, the detail, the action, the identity of who invoked it. I then build a message, and I look to see whether there's an error message element in there. The error message typically means it failed. If that's not present, it was a successful call. And I generate a different email message structure, depending on whether it was a successful call or a failure. And I then add on to the request the list of all the other API information. This is more for debugging so that I can debug the call later. I can see all the information that was included. And finally, I generate the SNS message. So this is where I call SNS and publish to their topic this message, and SNS will turn around and deliver it. So that's the Lambda function. And finally, the last piece I need to put is the CloudWatch Events to link the two together. To do that, I start with the event source, and I say this is coming from DynamoDB. I want to trigger on a CloudTrail event. So I'm going to trigger by an API call via CloudTrail, and I select one event, the delete table. This is for a sample. I'm only trying to track that one event. And this generates a particular structure for the CloudWatch event rule that shows it's for CloudTrail, it's from DynamoDB, and it's for the delete table API, the event name. I then set up a target to be the Lambda function. This is the function we created in the prior step, and that's the DynamoDB alerts function. And that's it. I'm done. That's all I have to do. And now when Jane goes and deletes her table, she gets a successful call, and I'm having trouble pressing the button. I apologize. And then when she deletes the call, I get an email notification again very quickly that, hey, Jane deleted the table. And so you can, deleting a table is probably a pretty important thing, and you probably want to know when someone's trying to delete a table or when someone is deleting a table so that you can react to it if it wasn't a table that should be deleted. And so this is a way that you can trigger that event and know when it's happening or when it's being attempted. Controlling access to your table. DynamoDB provides two layers of control. There's a basic authorization, which is standard, the action that you're taking and the resource that you're taking it with, so like describe table and the ARN of the table that's being accessed. And then we support fine-grained access control. Fine-grained access control gives you the ability to limit access to portions of the table. You can limit based on the leading keys. The leading key is essentially the key of the table that's being requested. So if I'm doing get item on item 101, 101 is the leading key. So this lets you control what rows are allowed to be queried or allowed to be requested from the table or updated in the table. The attributes are the columns. So this lets you control what columns, so I can see what attributes, or I can control what attributes can be requested and or updated by the user. The select lets you control the select parameter on a query or scan request. Return values lets you control what values are when you make a request to Dynamo, you can ask for update item, you can ask for the old values to be returned back. And the main purpose of having this context key is to allow you to have a model where you have write-only access, where I can say someone's allowed to update the table, but not see the other values or not see the old values. And so I can say they have update permissions, but their return values are not. They're not allowed to ask for any return values. And so that's its primary purpose. And then you can also control whether they're allowed to look at how much consumed capacity is returned. I'm not sure why that's there, but that is a control that you have. I don't have a good use case for that off the top of my head. I apologize. So for fine-grained access control, we're going to walk through a scenario. I'm using the product catalog table. This is one of the standard example tables that's available on the AWS documentation pages. This has a partition key that's the ID record. There are a set of data in there for books. Books have IDs that are in the 100s. They start from, I think there's like 3 or 4 books in there, that 101, 102, 103. They have a series of attributes, some that are pretty obvious for books, like ISBN, some of which are more generic, like title. And then there's a set of bicycles in the data set. Bicycles have IDs in the 200s, and they have a different set of attributes, although some are in common, like title, but they have a bicycle type and a brand. And then I have 2 users, Alice and Bob. And Alice, I'm going to set her up so that she can only work on books. So she can access this table, but she's only able to see or update books in the database. And Bob is going to work on bicycles, and he's only able to access or update bicycles, I'm sorry. And they'll be limited to the attributes that are available for each item. So Alice won't be able to add a book that has a bicycle type, and Bob won't be able to add a bicycle that has an ISBN. So there'll be restrictions like that. And so let's look at Alice's permissions. We start out with some basic global permissions like list tables. List tables, you can't restrict it. You either list all the tables or you can't list any of the tables. So it has resource star, and so she has the permission to list tables. Then we have a set of specific DynamoDB APIs for get item and put item and update item. These are the items she needs to do her job for managing books. And the resource is limited to just the product catalog table. So she's not able to access any other table. With this permission, she's only able to access the product catalog table. And so onto the conditions. This is where you, in the condition sections of the policy, this is where you start using the fine-grained access control. We'll start with a limit on the leading keys. And the way this is written, it allows leading keys that are greater than or equal to 100 and less than 200. So I have two numeric comparisons, one that starts with greater than or equal to, numeric greater than or equal to, and one that is numeric less than. And the reason why I use numeric, the other option I could have done with this is use, say, a string-like, and said string-like 1 star. And the issue with that, if you were to use string-like 1 star, is that if later I add another product that's 1,000 and 1,001, then string-like 1 star would also grant permissions to that product as well. And this is, I'm trying to be very specific for IDs numerically between 100 and 200. And so I wrote this value. The other thing you might notice is there's this for all values prefix on this. Leading keys is a multi-value context key. In a normal get item, there's only going to be one value on there. But if you do a batch operation, when you do 5 get items in a batch, they'll all be listed in the same context key. So it's a multi-value. So on a multi-value context key, you should always list for all values or for any values, depending on what you're trying to do. In the case with leading keys, I want to make sure that any key that she specifies, it is within this range. And so I use for all values. The next is the attributes. And again, with attributes, I'm also using the for all values, because when you request attributes from a table, you're requesting generally multiple attributes. It's not just a single attribute. And so it is a multi-value context key. And I use string like, and I list, and in this case, I could have used string equals as well, because I don't use any glob patterns, no stars, or no wildcards in here. And so, but I give her access to the ID, the title, the ISBN, the fields that we have allowed for books. So she's able to update these attributes. If she tries to update a different attribute or tries to see a different attribute, her request will fail. So Bob's permissions, I'm only going to show you the conditions section because the primary section was exactly the same. He has get item, put item on the same table, and he has the list tables for all tables. And so within his section, he has the IDs that go between 200 and 300. So greater than or equal to 200 and less than 300. And he has the access to the attributes related to bicycles. He doesn't have access to the attributes that are not related to bicycles, like the ISBN. So looking at some examples, here's a case where Alice is trying to access a record with number 99, with the ID 99. And this fails with an access denied. Now, I don't know if you're familiar with the product catalog table, but the product catalog table doesn't have a record number 99. But she still gets an access denied. And the reason for that is a security reason is she's not allowed to see whether there is a 99 or not, because she's not allowed to access 99. So she's always going to get an access denied whether or not the record actually exists. If she tries to access record 101, everything works peachy keen. She gets back her record because she's accessing the records she's allowed to access and the fields she's allowed to access. If, on the other hand, she tries to access a field that she's not allowed to access, such as the brand, she gets an access denied on the brand because she's not allowed to request the brand field. She's only allowed to request the fields that are relative to books. Again, it doesn't matter whether there's actually a brand or not on the record. She's asking for brand, then she's not allowed to see brand. Now with Bob making the request, he's asking for 199. There isn't a 199, and it's outside of his range. So he also gets an access denied. But when he makes a request for 201, the request is successful, and he's able to see the record. So on to limiting access when using Amazon DynamoDB, network access. The way you typically access, if you're coming from a VPC and you're on an EC2 instance, when you're going to access DynamoDB, what typically happens is you go out of AWS, out into the internet, and come back in. Right? So you're making a call that goes out through an internet gateway and accesses DynamoDB. And some people don't like that. They don't want to go out through the internet, and they want to be able to access Dynamo directly. And so we have this model where with a VPC endpoint, the access goes directly from your VPC to Dynamo, bypassing the internet. And it does not go out across the internet at all. And in addition, and so you can actually have a VPC that has access to DynamoDB that has no internet access. You do not need internet access anymore if all you're trying to access from the VPC is DynamoDB. In addition, you get to write policies on this connection, this VPC endpoint, that restrict who can use this connection and how they can use this connection. And so I'll talk through setting this up, setting up a VPC endpoint, as well as how you can control the policies, and some of the impacts that you have to be aware of when you're setting this up. Because when you set this up, the connection path changed. And that can have a negative impact depending on how you've constructed access to your database, what permissions you've given. So to set this up, you go to the console. And yes, you can do this in the CLI and other ways, but I'm going to do it from the console. You go to the VPC console, and you select your endpoints. And then on the endpoints, you're going to select Create Endpoint. And in this case, I already have an endpoint for S3, but I'm going to be creating an endpoint for DynamoDB. And when I go in, I get to select a AWS service, and I say I want to select DynamoDB to create DynamoDB. And you'll notice after that, there's this warning that shows up on your screen that says, hey, be aware that your source IP addresses are going to change. Because you're no longer going to be accessing this by going out to the internet where you have a published external IP address that's used to access the service. You're now coming in through an internal access. And this changes what IP address your user looks like, what IP address your user has when they come to access the service. And if you have policies that restrict based on IP address, that can break you. So an example is I have a policy for Bob. And in this policy, I've granted him access to DynamoDB star. And again, I'm going to say, you generally don't want to grant access to DynamoDB star. It's not a great policy, but it's good for examples. And in this case, I'm going to have a policy that grants access to anything in Dynamo as long as Bob is coming from the corporate IP address. This would be the public IP address of that EC2 instance that I was using as an example before. And so his request will work fine as long as he's coming from that IP address. When he goes to make this access and he lists the table, everything works peachy keen. But now, if I turn on the VPC endpoint, and then Bob goes to make the same exact request, he gets an access denied. And this access is denied because he's no longer coming from that source IP address. In fact, the way it works, when you come in from a VPC endpoint, we don't populate the source IP address in the authorization context. So the source IP is not available. And the reason why we don't, even though he does have a source IP, is coming from an internal IP address, the reason why we don't populate that is most AWS VPCs have the same IP address range. There'll be 10.0.0.0/8, many of them. And so everybody would have the same IP address. And so you don't want to populate a data that's shared by many customers. And so we don't populate. If you're coming in through a VPC endpoint, you cannot have a condition that's based on the source IP address. But you can have conditions where you populate other context keys. One is the VPC endpoint that you're coming in through, and the second is the VPC that you're coming from. So you have a source VPC and source VPC endpoint. And so to update Bob's policy to allow this. Now, this is a case where I want to allow Bob to still be able to come in from a corporate IP address if he's coming in from the office. And so I set it up to limit on the source IP if it exists. And so what if exists does, it says this condition, this restriction to source IP only applies if the source IP condition key has been set. It does not apply. It's ignored if the source IP is not set. And similarly, I add a condition string equals if exists to the source VPC endpoint. So I put in my VPC endpoint in here so Bob can access it if he's coming in through the source VPC or if he's coming in through the source IP. So that's the effect of having the if exists on the two of them. It can be either or. Either one will match. And this works because we do not set both of them simultaneously. You will, in your authorization context, you will not have both a source IP and a source VPC endpoint. Alternatively, if I said, oh, Bob is only going to access it from my EC2 instance, and I only want him to be able to access it when he's coming in on the source VPC, and this would prevent Bob from being able to access it from his system at home or his work laptop running inside your corporate network. He'd only be able to access the data from the VPC endpoint if he's connected through the VPC endpoint. And so you can write the policy so that it only allows it when you're coming into the VPC endpoint to restrict Bob. So this is something you have to be aware of if you're going to go turn on VPC endpoints. If you have policies that restrict based on IP address, you want to fix that and address that before you turn it on. Because as soon as you turn it on, it will stop source IP restrictions. So continuing my setup, I need to attach the VPC endpoint to a VPC and route table. And now I have my VPC endpoint set up. There's another thing I can do, which I mentioned before, is I can set a VPC endpoint policy. VPC endpoints are a connection, and they have a policy where you can control what goes across the connection. And this policy is a little different. Even though it'll use the term allow, it actually doesn't grant any privileges in and of itself. It's a limit policy. It's the net effect is the permissions of the call are what the IAM user's permissions had intersected with what the VPC endpoint policy has. So you only have the permissions that are the connection of the two together. But if I put an allow in the limit policy, it doesn't grant any privileges by itself. You can't, just because I have that allow, doesn't mean a user is going to be allowed to put something in DynamoDB. But it does allow you to control that. It lets you control what principles, what actions, and conditions that they're able to make the call under, and what resources they're able to access. So this allows you to do some things, and I'll walk through a couple of examples here. The default model, when you're going to set this up, is full access. This essentially is a VPC endpoint policy that says allow star to access star. It's allow star and star, so any user can use the VPC endpoint policy to access any DynamoDB table coming through there. That works well, and you have to be aware that if you have other DynamoDB, other applications using DynamoDB that are running within your VPC, that maybe not be they're not using your corporate DynamoDB, they're using their own DynamoDB as part of their application because it's a third-party application. You have to make sure you don't break them by turning on the VPC endpoint, so you may need this in some cases. But let's assume you're going to write a VPC endpoint that says, I only want my own tables to be accessed. And in this case, I'm in account 676 blah, right? And in that account, I only want users to be able to access tables from that account. And so I put in a policy that says allow principal star, so I don't care who the principal is, access to any DynamoDB API, as long as the resource is an ARN that has a star in the region, and I'll explain why that is in a second, and a star at the end. So I don't care whether it's a table or an indice or a backup or a stream. Any DynamoDB resource in that account is allowed to be accessed. This prevents someone from accessing a DynamoDB resource in another account. And why might you want to do that? If you're concerned about data exfiltration, right? Any AWS credentials can work from any EC2 instance. And I'll walk through an example where I have a foreign Alice is able to go and access DynamoDB from within an EC2 instance in my account. The one other part of this policy, I have a second part where I have describe tables, describe limits, list tables, and list backups. And here, those resources, they don't have resource level controls, so you can't limit them. You can't restrict list tables to a particular table. And so you have to grant those resource star. And so I include this particular statement in there to allow those commands to work as well over the VPC endpoint. And in reality, it doesn't really matter if someone's able to list tables in another account, as long as they have permissions in that other account anyway. I'm more worried about whether they can send data or pull data in from another account, and that's why I limit the basic permissions. And so I did use any region here, and generally a VPC endpoint only exists within a single region. And so I could, if this was in US East 1, I could have put US East 1 in here. I use star only because I expect that I want to use the same VPC endpoint policy in multiple places. And rather than having separate versions for every different region, I can just take this one VPC endpoint policy and stamp it out and set it up in each region. And so it will work in any region. But this would have worked just as well if I had put US East 1 in there, if this endpoint was in US East 1. And of course, any resource that I wanted to access. And so here's an example. I use this call, STS call, get caller identity. It's kind of a useful call if you find credentials lying around and you want to know what account they're in. I do a lot of playing with AWS, and so I have many different roles and many different users, and sometimes I forget which account they're in. And so you can always take those credentials and say AWS STS get caller identity, and it will come back and tell you who that is, what account they're in, and what the ID is, what role it is, or what user it is if it's an IAM user. So here I have that on the EC2 instance. I ran this call in EC2 instance, so it's using EC2 instance credentials. And the instance is running inside the account 676. That's my account. And then I have this foreigner called Foreign Alice. And she has credentials on this platform. And these credentials show that she's in a different account. So this is just an IAM user who has a access key ID and a secret key. And they're in account 512 blah. Right? So different account altogether. With that VPC endpoint policy I created, without that VPC endpoint policy, if we ran with foreign Alice, she's able to list any table, and she's also able to describe table or get item or put item on tables in her account, right? She's not limited to just table, she's not limited in, even though she's running in my VPC, in my account, on my EC2 instance, she's able to access records in her own account. If I then turn around and set that endpoint policy I just specified, which limits access to only my account, when she tries to make the same call, she gets a failure in that she's only allowed to access, she's not allowed to access the table that, because it's not in my account. So I'm blocking access to the table. In some cases, you might want to limit this to tables within your own organization. So you might, instead of having just one account, you want to limit to all the access to any table within my organization. And so you can use the context key that IAM sets, the principal org ID context key. And you can put in your VPC endpoint policy, allow any principal. So that looks like it's very broad. It says any principal in any account, and resources star, so any resource whatsoever. But the condition is only when they're in my org, right? So the principal has to be within your own organization in order for this to succeed. And so that limits the access to just within your own organization. So it's another way you can use the VPC endpoint policy to be restrictive, but not necessarily as restrictive to just the same account. So to look at some other stuff that you might want to look at, related to security, although not directly, but continuous backup and point-in-time restore. And this, even though it's not exactly a security feature, I think it's pretty important from a security point of view because it's inexpensive, it's easy to set up, and allows you to restore your data at any point in time, including if someone deleted your table. Even if someone deleted your account or suspended your account, the table is still there and available for 35 days. So you have that data as a backup, as a persistent backup that's maintained outside of the account as a way of protecting the data. The other thing you can look at is AWS config and monitoring. There's some config rules that you can use to monitor your account and make sure your tables are encrypted, or make sure your auto-scaling is enabled on your tables on an automatic fashion. So thank you for being here. Please make sure you fill out your